In my previous video, I discussed the topic about area between curves. So this time, I am going to discuss the second application of the definite integral. Uh, this video is about determining the volume of a solid of revolution. Okay. Let us first define what a solid of revolution is. A solid of revolution is a solid obtained by revolving a region in a plane about a line in the plane called the axis of revolution, which either touches the boundary of the region or does not intersect at all. So we are talking here of a plane area in a plane man. So we are considering only two axes x and y, and then we are going to revolve the region about a line in the plane. So our line is either horizontal or vertical because our rectangular strips is either vertical or horizontal also. So the condition is that the axis of revolution must either touch the boundary of the region or it does not intersect at all. Therefore, you cannot revolve a region about a line which intersects the region. So let me illustrate. Suppose you have this region, bounded area. It's an area bounded by a parabola and a line. Okay. So the boundaries are the points of intersection, 1 and 2, and the vertex. So suppose we are going to revolve this area about a horizontal axis or the x-axis. So our line or our axis of revolution must either be or must either touch the boundary or it will not intersect at all. So one possibility is this. Our axis of revolution is the x-axis and it touches this boundary, the origin. So pwede, no? Or at a certain distance from the vertex. Yeah, it's possible also. Or this point, this line, where it touches this boundary or at a certain distance. Uh, or for vertical lines or vertical axis of revolution, okay, if you revolve the area about the vertical axis, you cannot revolve the area about y since the y-axis intersects this region. So, dili pwede. It's not possible. Okay. This one. It's okay to revolve this area about this line since this line intersects or touches the boundary or at a certain distance from the boundary or this one, yeah, or at a certain distance. Uh, So those lines which intersect the region are not possible or you cannot revolve the area or the region about lines or about those axis of revolution which intersect the region, like this one. You cannot revolve the region about this line or this one, since the line intersects the region. So always remember or bear in mind that the axis of revolution must either touch the boundary of the region or it does not intersect at all. Okay. So there are three ways of determining the volume of a solid of revolution, or three methods. The first method is the circular disk method. Okay. Now, suppose you have this region bounded by the curve y equal to f of x and the interval a to b and the x-axis. And you want to revolve this area about the x-axis. Now, if you're going to revolve the whole area, you will get an irregular solid. So, finding the volume of an irregular solid is not easy. Therefore, what we'll do is we will make use of the rectangular strip. So, instead of revolving the whole area, we are going to revolve only the rectangular strip, either vertical or horizontal, for all methods. So for this one, circular disc method, what we will get is a circular disc. And that will happen if our rectangular strip is vertical. So if we revolve this rectangular strip about the x-axis, we will get a circular disc. Okay, like this one. So this solid is the solid of revolution when this region is revolved about the x-axis. And for this rectangular strip, after revolving this region 360 degrees, you will get this one. So what you will do is focus on this one and you'll get dV, differential volume, because you are only considering one differential element. Okay. So you have dV and then you integrate to get the total volume. Okay. Another illustration. You have this region or plane area and you want to revolve it about the x-axis. And in order to get a circular disc, you must consider a vertical strip, okay, so that you will get a circular disc. If you will consider a horizontal rectangular strip, you will not get a circular disc, and that will be a different method. So the result when you revolve this area about the x-axis is this. Mm. And for this rectangular strip, after revolving, this is what you will get, a circular disc. And the last one is this. And you want to revolve the area about the y-axis. So for a circular disc, the strip must be horizontal. Para after revolving, you will get a circular disc. Okay. So one thing to remember that for circular disc method, your rectangular strip must be perpendicular to the axis of revolution. Like this one. The axis of revolution is horizontal. Therefore, our strip must be vertical para perpendicular sila. For this one, since our axis of revolution is horizontal, then our strip must be vertical. For the third one, since our axis of revolution is vertical, then our strip must be horizontal para perpendicular. Okay, that's the first thing that you will consider. No? The second is that you will get a circular disc if one end of the rectangular strip touches the axis of revolution. As you can see, one end of the strip touches the axis of revolution. For this one, ni-touch ang one end sa rectangular strip sa axis of revolution. As well as this, one end sa strip touches the axis of revolution. So again, two things to remember. The first one is the strip must be perpendicular to the axis of revolution. Second, one end of the strip must touch the axis of revolution. So after complying those two things, or masatisfy na nimo, and you will get a circular disc after revolving the region. So first, let us know the formula for a circular cylinder. What's the volume of a circular cylinder? So we have this circular cylinder, right circular cylinder. Base radius r and height h. The volume is pi r squared h, or simply area of base pi r squared times height or thickness h. So for a circular disc, that would be differential volume dV, because we are considering only one circular disc. No? So dV, our height will be dH also. We cannot change R because R is constant all throughout. From top to bottom, the base radius is constant. Okay. So dV, dH. Yeah. So illustration. Again, you have this area and you want to revolve this about the x-axis. So therefore, you will analyze a vertical strip. And once ma-revolve, okay, our notation sa as what was discussed area between curves. Now, for a vertical strip, our notation is y up and y down. But by inspection, our y down is 0. So we only have y up, or simply y. No, y lang. And then you have this one. After revolving this strip, and you will get the circular disc. Y being the radius, because this is the center of the circle. So y radius thickness dx. So our differential volume is this: pi radius squared times thickness dx. So after this one, you integrate and you get the total volume. Okay. So another one, if you want to revolve the area about the y-axis, you consider a horizontal strip, and after revolving, you will get a circular disc. Okay. Now, as what was discussed sa area between curves, pag horizontal strip, notation nato are the following: x right and x left. But by inspection, our x left is 0. So we only have x right, x sub r, no? Or simply x lang. Pwede ra x. Uh, or you can write x sub r, pwede. So by revolving this strip, you will get this. And the radius is x, thickness is dy, no? Okay, of course, ang height na to or ang thickness is along the vertical man, so dy. For this one, ang thickness is along the horizontal, and so we have dx. So volume dv is pi r squared times thickness. Okay. Okay, let us solve some problems. Find the volume of the solid generated by revolving about the x-axis, the region bounded by the curve y equal to x cubed, and the lines y equal to 0 and x equal to 2. Okay. So first is you have to sketch the graph. Make sure that your graph is correct. Yeah. So how do we sketch this one? Y equal to x cubed. It's very simple. All you have to do is assume values of x, let us say from -3 to +3, and then you compute for y. Example, x equal to -3, y equals -27. So -3 ang x, -27 ang y. When x equals -2, y equals negative 8. Negative 2, negative 8. X equal to negative 1, y equals negative 1. So if we will continue with that, this is the graph of y equal to x cubed. Okay? Now, the line y equal to 0 is simply the x-axis. It's a horizontal line, di ba? Like y equal to 0, y equal to 1, y equal to 2, y equals 3, y equals 4. So horizontal line. Okay? This one. That is y equal to 0. And x equal to 2 is a vertical line. So x equal to 0, x equal to 1, x equal to 2, x equal to 3. So x equal to 2, we have this. Okay. So this is our bounded region. Now, let's go back to the problem. You revolve this area about the x-axis. Okay? It revolves x-axis. Therefore, since our axis of revolution is horizontal, our strip must be vertical. Like that. So pag vertical, y up minus y down. But again, our y down is 0. So we only have y up or simply y. And then thickness of dx. So let's revolve the rectangular strip and we get this one. Our radius is y and our thickness is dx. And our differential volume is pi y squared dx. Area of circle times thickness. So let's integrate. Integral of dv equals to integral of pi y squared dx. So all you have to do is you replace y by x since dx man. So you replace y by x. Okay, you get it from the equation y equal to x cubed. And then for our limits, values of x also kay dx mo. So our boundaries are x equal to 0 to x equal to 2. So we have this. So y is x cubed and then squared y squared. Using law of exponent, x cubed quantity squared is equal to x raised to 6. So sa law of exponents, if you have two exponents, you will multiply the exponents 3 times, so you have 6. This is the result. And after this, use the power rule, integral of x raised to 6 dx. Uh, Once you get the derivative, the antiderivative rather, evaluate from lower to upper limit, and you now have the volume. Okay. So you evaluate lower upper and minus lower. The answer is 128 over 7 pi. So it's very simple. Second problem. Compute the volume of the solid formed by revolving the region bounded by the curve y squared equal to x, y equal to 2, and x equal to 0 about the y-axis. So again, you sketch the graph. Y squared equal to x is a parabola opening x to y, opening to the right, kay positive man. Pag negative, opening to the left. So this is opening to the right with vertex at the origin. So this is your parabola. Okay. And then y equal to 2 is a horizontal line, y equal to 0, y equals 1, y equals 2. And x equal to 0, it's a vertical line. X equal to 0, x equal to 1, x equal to 2. So this is the y-axis, x equal to 0. So this is our bounded region. And we want to revolve this area about the y-axis. Okay. So therefore, our strip must be horizontal since our axis of revolution is vertical. So, okay. This is our strip, and of course, x right and x left, but x left is equal to 0 since it touches this line, y-axis. So we have x right or simply x, and then thickness niya dy. So once ma-revolve, and you have a disk, ang radius is x, thickness dy. So our volume is pi x squared dy. And then we integrate and we have this integral of dv equal to integral of pi x squared dy. This time, dy man, so we will now replace x by y from the equation of the parabola. Okay, so x replaced by y squared, and we have this. Our limits, since dy, so ang limits na to y is from 0 to 2. Again, using law of exponent, this is equal to y raised to 4. Products 2 and 2. And using the simple power rule, you integrate y raised to 4 dy. We have this. And then you evaluate from lower to upper limits. And the answer is this. 32 over 5 pi. And this example, find the volume generated by revolving the area bounded by the curve y equal to e raised to x, y equal to 0, x equal to 0, and x equal to 1 about the x-axis. So let us get this one, y equal to e raised to x. Again, if you have no idea what's the graph of this, you can use your calculator. If you're using Casio 991 ES or ES Plus, or you can do it sa mode 7 table, or if not, you can just substitute values of x uh, ranging from -3, probably -3 to +3, or depende sa gusto nimo. So for example, e raised to -3, you compute for y. Next, e raised to -2, you compute for y. And then connect all points, and you will get this one. Okay. This is the graph of y equal to e raised to x. Now, the graph intersects this point. This is the y-intercept. And to get the value of this, simple. It's simple. Just set x equal to 0, because at this point, for y-intercept, x is equal to 0. So e raised to 0, y equals 1. So the value of y is 1. So the region is bounded by this curve, y equal to e raised to x. Y equal to 0, horizontal, the x-axis, x equal to 0, y-axis, and x equal to 1. So our region is this. Now, going back to the problem, this area will be revolved about the x-axis. Okay? So it revolves the x-axis. Therefore, our strip must be vertical so that we will get a circular disc. And y lang, instead na y up, you can use y. No subscript. Since our y down is 0. And then thickness, dx, you revolve, And you will get this one, circular disc, radius of y, thickness dx, and then this is our dv, area of circle times thickness, and you integrate, you replace y by x, and limits na to dx, so our limit is from 0 to 1. Okay. So you replace y by e raised to x. By law of exponent, this becomes e raised to 2x dx. Now, this is not a common formula, no, or a standard form rather. This is not a standard form, integral e to the x dx. Our standard form is integral of e raised to x dx or integral of e raised to u du. So, in order to transform this one to standard form, we have to change this one to u so that we will have e to the u. So, the technique that we are going to use is change of variable. Substitution, the u substitution. So let u equal to 2x du to dx. Solving for dx is du over 2. Now, since we change the variable from x to u, we will change also the limits from x to u. So when x is 0, u is also equal to 0. 2 times 0, 0. And for x equal to 1, 2 times 1, u is equal to 2. So by changing the variable, this is our new integral from 0 to 2 na. Okay, u1. And e to the u, our dx is du over 2. So 1 half, you combine sa pi, written outside the integral. Integral of e to the u is e to the u du is e to the u. Okay. And then evaluate the limits from 0 to 2. And then compute, and the answer is 10.036 cubic units. Okay, so that's it. So I hope that you have learned something from this video. Again, always remember those two things in analyzing or in using the rectangular strip. So to get a circular disc, always remember that the strip must be perpendicular to the axis of revolution. And the second is one end of the strip must touch the axis of revolution. Uh, uh, Thank you for watching.